Good afternoon, folks. Welcome to the last session of Ignite. I'm sure that you're all pretty shattered after, 3 days now of learning. So I thought I'd finish you off with something nice and simple, easy to absorb. As you can see, this is a safe one. This is a 300 level talk. They have given it the number 385, so I'm allowed to make it 85% of a 400 level talk. I'll begin with a couple of warnings. The first one is Roslyn is not a product that I work on. I do work for Microsoft. I work, however, in Azure Batch, but I've been using Roslyn to work on some internal tools for our team, which is where this has come from. But I don't know Roslyn backwards, forwards and sideways, so you may well be able to catch me out on some of the details. The second warning is that at 11 o'clock this morning, Microsoft IT started installing the new version of Office on my laptop. So I don't know what's going to happen in the next hour. I don't know. Oh no, we're good. 0% complete. So yeah, we're safe. I want to talk about how you can use Roslyn to build internal tools to work with your colleagues, to work with your projects for your particular team and project needs. And I thought I'll make a bit of a joke of the title, and got a bit of pushback from the Ignite guys. Use your powers for good, not evil. What is this? What is this new Microsoft nonsense? But, all right, so be it. So, new title. Everybody hug. There we go. Right. Enough of that. So, what is Roslyn? Roslyn is the new C# and Visual. The new. It's not mine. The timeline is mine. Roslyn is the new C# and Visual Basic compiler. It ships in Visual Studio 2015. It has been talked about. I think Anders Heilsberg has been demonstrating it, promising it since I think build 2008 or something like that, when he was previewing C# 4. So it has been going for a little while. It was open sourced in April. It was announced and open sourced in April of last year. And it's been available in preview for quite a while. It is now in Visual Studio 2015. It is the main compiler in 2015. And a lot of what I'm going to show you today, therefore, only works in 2015 because it relies on that Roslyn integration. But there are some things that you can do that will work with older code bases as well. What does Roslyn give you? Well, firstly, of course, it gives you a compiler. You can produce assemblies. Go you. At a more interesting level, it gives you what Heilsberg calls a compiler as a service. It gives you the ability to hook into the different bits of the compiler, and we'll see some more information on this later, and use parts of it as you choose to build your own tooling, your own capabilities. So, for example, it gives you syntax trees for code. Do people know what a syntax tree is? Is that a familiar term to people? Yes? No? Yeah, okay. So a lot of people, yes, many people know. So we tend to think of code as a linear thing. You write some text, you rattle it out, you save it, you ship it, you test it. No, wait. When the compiler sees that code, it has to think about it in more the way that you would when you're trying to analyze it yourself. So it will break it down into a tree of, okay, I've got a namespace, and that namespace has got some classes in it, and each class has got some members in it, and the members have got, the methods have got bodies within them, and the bodies consists of statements, and each statement is broken down into, and so on and so forth. So you can see that nested syntax tree. That's a pretty common thing with compilers. Roslyn has to go one better than that, though. Because Roslyn lives in the Visual Studio environment, because it powers a lot of Visual Studio features like IntelliSense and code completion, sort of formatting, things like that, Roslyn has to deal with broken code a lot. Because most of the time when you're editing, your code is broken or invalid. Most of the time you're in the middle of typing something. And therefore, the compiler has to be able to cope with the fact that actually you've got something that's not properly semicolon separated. You've got a variable that appears to end in the middle of a line and pick up on the next line because you haven't finished typing the name and put the semicolon into it yet. So it's got to cope with these very difficult and complicated, invalid environments. It gives you a semantic model, which is once Roslyn has broken down the syntax into, I've got some tokens here and they wrap around these other tokens and it's all like this. It can then go, well, actually, let's see. Now that reference there refers to that thing there, that one refers to that thing, that must be a type, and that type contains these members and that's property, and so on and so forth. So you've got a semantic model that understands a bit more of the meaning of the code, the kind of symbol, the data flow within it, that kind of stuff. And then the top level is the Visual Studio integration. That's not something you have to take on board. I'll show you later on how you can use Roslyn completely independently of Visual Studio. It is just a pile of DLLs, but it also comes with some features that integrate it into Visual Studio. So Roslyn is not just a compiler. It's a platform that you can use to build tools using those compiler as a service features. And that could be things like static analysis tools. They can provide fixes to mistakes that your colleagues make, not you, obviously. They can do refactorings for you. You can use them to implement style guides by, again, looking at the code, does it conform to our style guide? You can use it for code generation. One of the things that hasn't shipped yet but is going to in 1.1 is scripting. So there will be an interactive window in Visual Studio where you can write C# expressions and evaluate them, just back and forth. And that will also, I think, be available as a console application similar to Script CS, which some of you may have used, which is again a scripting tool, command line tool for C#, which has been shipping for a while based on preview versions of Roslyn. You can use it to do code metrics, and you can also use it to work with your documentation, your / documentation comments. Now, you can do all this at the moment. You can get C# parsers. You can use ReSharper as a basis. You can build ReSharper plugins. What Roslyn does is it significantly lowers the barrier to entry. It makes it so much easier to build your own tools and therefore to build them to your own particular needs rather than relying on what other people are willing to ship for you. I mentioned also that Roslyn is open source. It is Apache licensed. That means that you can fork it as much as you want. If you want to create your own dialect of C#, I can't possibly condone that, but hundreds have, so go for it. You can raise issues on it via GitHub. So a lot of the discussion about language evolution and bugs and what features should be prioritized, that is happening out on the open via GitHub issues. So you can go to github.net/Roslyn, pitch in, have your say, participate, and you can even, if you want to fix a bug, then you can do it and send a pull request. The team are accepting pull requests, though probably not for your crazy language feature just yet. You might need to negotiate for that one. So Roslyn is a traditional compiler pipeline. It follows the traditional compiler pipeline, where you do sort of your parsing stage, then you do your analysis of that to produce your symbols, then you kind of hook everything up together, and finally you emit all the stuff. You emit the binary at the end. In terms of the Roslyn APIs, those stages map to the syntax tree API, the symbols API, which is part of the semantic model, the binding and flow analysis APIs, which are another part of the semantic model, and finally to the emit API. And Visual Studio features are then built on top of those. You can see I've helpfully put the text sideways to make it easier to read on that diagram. So the baseline stuff like the formatter, the colorizer, and outlining, all that needs is the syntax tree. It doesn't need understanding of the code, it just needs that basic parsing. Whereas things like F12 navigate to or find references or rename or whatever needs more of that semantic model to understand where things are used, how things fit together. And then you've got obviously compilation and edit and continue kind of features, which use the emit API. So hopefully that gives you some sort of picture of what Roslyn is and what the bits in it are. What I'd like to do now is just sort of dive in and show how you can actually use it to implement a tool that might be relevant to your team. I'm afraid the examples I'm going to use are going to be a little bit generic because I don't know what your particular team needs, but I'm going to show you some that I've been looking at for our internal usage, which maybe will give you some idea of more specialised applications you can make of this stuff. So creating a Roslyn project, a Roslyn analyzer as they call them, is pretty easy. File new project. There's this extensibility tab in the create project dialog. You choose analyzer with code fix, and okay, and it then downloads all the NuGets, all the NuGets, all the NuGets. Roslyn isn't actually all that enormous, but we haven't got a particularly fast network connection, and it's sufficiently enormous to be kind of annoying. So what has it given us? Well, it's given us a README, which I'm not going to let you read because I want you to listen to me instead. Ha! What's it given us? It's given us 3 projects in the solution. It's given us an analyzer class, a test project, and a v6. And the way that an analyzer, a Roslyn analyzer builds, it actually builds in 2 ways. The main way you would want to use it most of the time is the NuGet build. So when I build this analyzer, it's going to produce a NuGet package. But doing testing with NuGet packages is kind of a pain in the arse because you don't want to have to keep deploying them to some sort of local NuGet store or something like that. So they also build it as a v6. A v6 is a Visual Studio integration component, which means that basically it can be run up as a global thing that sits as part of your installation of Visual Studio. The important difference is v6 is kind of per person. It sits in your installation of Visual Studio. NuGet is per project. It's a reference. And that means that it travels around with the project, and once you've managed to get your style guide or whatever committed into source control, it gets inflicted on everybody else. Everybody. Yes. It is an intoxicating power. The other thing it's given you is a unit test project, because if there's one thing that's even slower than mucking around with NuGets, it's mucking around with v6s. You don't have to test interactively by running up an instance of Visual Studio with the v6 installed every time you want to try making a change. And this kind of illustrates that these things can run outside Visual Studio. They can run in the MS Test or XUnit or whatever environment. All right. The illustration I want to start with is a simple style guide, and it's for a convention that I think a lot of teams use, which is private fields should be prefixed with an underscore, private fields in a C#. I should mention, Roslyn works for C# and Visual Basic. I'm not going to talk about Visual Basic, but it's all the same. If you use Visual Basic, it works in the same way as this. Some of the names are different because Visual Basic's got different syntax, oddly enough, but basically everything works the same. So we want to have a warning come up whenever somebody creates a private field without that initial underscore. So what have I got for that? Well, what I need is one of these diagnostic analyzer classes. That's a base class defined by Roslyn, and it's got a few interesting methods or properties. It's got the supported diagnostics collection, which is basically just says, this is the set of diagnostics that I want to export to whatever's consuming me. This is the set of diagnostics I define. It's got a initialize method where you register the actions that you want to pay attention to. So in this case, I'm interested in field declarations, so I want to register a symbol action on symbols of type field. And then I've got the work that actually does the method. So this registration, you can see I'm passing in a callback. So whenever Roslyn, whenever Visual Studio or the C# compiler decides to look at a field symbol, it's going to go, I've got a diagnostic for that, I will call that callback. So whenever it looks at a field, it calls this analyze symbol callback. And that's pretty simple. It says, all right, I'm confident I'm going to be looking at a field symbol in this case because I asked to be told only about field symbols, so I'll just do a cast. Now, I will look at the name of the field symbol, the name of the field, and I will say, does it start with an underscore? And if it does not start with an underscore, then I will report a diagnostic. And the information about that is the diagnostic rule, which is just sort of the metadata and the location of the field. And in my case, I've also added a little dictionary saying which field name it is. Why did I do that? Because it will save me doing some lookup later on when I come to fix that problem. And you'll see why. So the easiest way for me to test this thing is to use the unit tests. And I can do some simple tests like, that shouldn't produce a diagnostic. If I've got a private field that has got an underscore, then that should produce no diagnostics. If I've got a field that does not have an underscore, then I'm hoping that I will get a diagnostic, and it should look like that. It should contain that message, it should be a warning, and it should be at the right position. The way you know that right position is you run the test repeatedly and watch where it fails and says, oh no, this was on line 17. Okay, line 17, run again. Oh no, it's in column 43. All right, column 43, run again. Pass, hurrah! Couldn't make it any easier, could you? These are little helper methods that are provided by the generated unit test project that just say, look, I want to just check that the diagnostic that's produced is the one that I see. So if I run this test, and yeah, there you see what the hyper-optimized nature of MS Test meeting the highly specified Microsoft corporate laptop does to test performance, but I didn't have NUnit on here. So my test has passed, I've got the correct diagnostic out. Life is good. But that's not really very satisfying. I want to see wiggles, I want to see squigglies, I want to see programmers being blamed in real time. And that's where the V6 comes in. So if I F5 this, then it will launch what they call an experimental instance of Visual Studio. It's not the main experimental instance, there's multiple experimental instances, and it all gets kind of confusing and scary. But in this case, it will launch the black instance of Visual Studio. This is proper Visual Studio. I mean, this is just Visual Studio 2015. It's been told to use a different set of. It's essentially been told to use a different profile, different set of registry entries, different set of extensions, and that means that if I go look in extensions and updates, then somewhere in here we will see my naming convention analyzer has been installed into this Visual Studio Hive. And I can then open up a project in this Hive, and here is a program. Here it declares a field. The field has no underscore. Blame. And of course, if I want to fix that, well, I put the underscore on there and the wiggly goes away. That's a different wiggly. Yeah, that's a different wiggly. I didn't mean to show you that wiggly yet. There we go. If I rename it properly, then the wiggly... I've installed too many V6s in this one. Anyway, you can see that that one is not the... this is not the warning you are looking for. But all that work, typing that underscore, man, it's hard. Let's come out of there. So the other thing that gets created in the template project, from the template project, is something called a code fix provider. And a code fix provider is a thing that looks out for diagnostics and says, I know how to fix those. In theory, these are decoupled. In practice, the template gives you the code fix provider and the diagnostic analyzer together. They're actually kind of decoupled, and the diagnostic analyzer says, here's a problem. And then code fix providers kind of hang around and go, any problems I can help you with? So you don't necessarily have to have them bound one-to-one. But often you will do, because often, if you see a problem, you know what the solution is. So here we go. What have we got? We derive from the code fix provider base type. We advertise which diagnostics this code fix provider knows how to fix. We write some boilerplate because it's a Microsoft template and there's always boilerplate. And then we override this register code fixes async. And this is something that, again, the infrastructure is going to call that when it sees a diagnostic that we say, that this code fix provider says it knows how to fix. It's going to be asked to register the code fixes that it can provide. It's going to be asked, well, okay, you say you can fix this. What are you going to do about it? What's your idea? What's your smart idea? Program. Well, what is its smart idea? Well, firstly, again, it does a bit more of a little dance. It says, well, where am I? I'm in some sort of document, and I need to get hold of the syntax tree. I need to get hold of the diagnostics, and then I want to actually find the thing that is referred to by the diagnostic. And here we do a sort of dainty little dance. Firstly, we say, what is the token at the location of the diagnostic? So what is the thing that Roslyn has parsed at that point where the diagnostic is being reported? And you might think, cool, okay, we've got this find token method, we found the token, life is good, that's our field. It's not so easy. It's never so easy, never with Roslyn. Because that syntax tree goes deep. That syntax tree contains all sorts of crazy stuff. It contains semicolons, it contains white space. It breaks down these declarations into their little atoms. So actually, what I need to do is find that token and then walk up the tree until I find the field declaration that contains the location of the diagnostic. And then I can go, right, I can register a code fix. It applies to this diagnostic. It has a title, which will be displayed in the user interface, and it's got a callback so that if the user selects it, I will call that callback. Well, okay, what does that callback look like? What do I do to fix this thing? Well, now at least I have my field declaration because I looked that up earlier, and I've passed it into my callback. I'm going to look, and again, fields are problematic because you can declare multiple fields at once. You can go int I, j, k. You can declare all of those in the same field declaration. So we look up the first one that we can see that corresponds to the one that the diagnostic was on. We then transition over to the semantic model. Why do we do that? Because the syntactic model, the syntax tree, only gives this sort of really low-level tree, these atoms that the document is made up out of. We need more understanding than that. Because we're going to rename something, we need to understand how it's used, where it's used. We need to have the symbol that things can refer to. So I get the document's semantic model, and I use that to look up the field symbol. The symbol, the semantic symbol that corresponds to that field declaration. And then I do the easy bit. I work out the new name. And then I want to replace the old name with the new name. Again, you might think that'd be kind of easy. Well, I'll just do a replace in my syntax tree. But this is Roslyn, and things are never easy, because all Roslyn data structures are immutable. You cannot modify the existing syntax tree. What you can do is produce a new one. Someone's chortling. I've broken somebody already. So how do you do that? Well, in this case, the answer is you cheat. You grab the original solution, you grab some of its metadata, and you say new solution equals renamer.rename symbol. I don't have to worry about all of these crazy problems. I will just say, go through the solution, rename that field symbol with this new name. And then that's going to produce a new solution object. Doesn't modify the existing solution object because immutable, produces a new solution, and I then return that new solution from my code fix provider. And what does that look like in practice? So there's my thing that's complaining. I can use my usual control drop down, and there's my new code fix that's been put in place. There's my text, and there's a preview of the changes that it's going to make. So Roslyn has, or Visual Studio has called that code fix provider, figured out what I'm proposing to do, what the code fix provider is proposing to do, and is showing me a preview. I've not had to do any work to get that preview or anything like that. I've just had to say, this is my proposed new text. And so I can go, yep, I want to do that. And you can see it's been changed in all the places because of the magic of the renamer. All right. All this is using the v6 in the black instance, which is not where most people are working, and you don't have to force people to install stuff. You want to be able to force the Torment upon them rather than them having to voluntarily install the Torment. So how's that going to work? Well, if I have a look at the output of this, you can see, as mentioned, it generates a NuGet package. And I can use that NuGet package in a project. Here is a project that violates my style guidelines. Notice, in this case, because we're in the blue instance, where those crazy v6s have not been installed, there are no wigglies. There is no complaining. Somebody is getting away with it in my team. This will not stand. So, let's not do that from there. Manage NuGet packages. Strangely, I didn't deploy this to the internet. So I've just got it locally, so I will install that into this project. It has a bit of a think, and I have blame. And now when I commit that, that NuGet reference is part of the CS proj. So when somebody else wants to use that CS proj, they will pick up that NuGet reference as well. They will pick up that analyzer as well. Now you may be going, oh, well, that's all fine and dandy, but there are only warnings. I can't actually stop somebody. I can't stop someone in their tracks out of petty bureaucracy. Oh, you can, though. Let's go in there. Let's go into references. And I'll just widen that out a bit. See that we've got some of our references are analyzers. If I pop that open, you can see that my NuGet package has appeared under the analyzers folder rather than the main set of references. And under there, it lists all of the diagnostics that are in there. And set rule, set severity, come to Papa. There we go. Red wiggly, do not build. And lest you worry, yes, of course, that severity is now part of the project. It's now become a code analysis rule set which travels again with the CS proj. No one can escape your clutches. But you say, but we use good build practice. We don't let developers just build in Visual Studio. We make them submit things to build servers and build there. What if one of my colleagues thought, it doesn't compile on my machine, but what the hell, I'll commit it anyway. Do you have colleagues like that? Anybody? Yeah, people at the front, they're nodding. Yep. Do you think they can get away with it? Let's have a look. So, Microsoft has got your back, don't worry. So let me clean that. Let me try to clean that. There we go. And here I am in a command prompt for my victim project. And I will just go msbuild, analyze NuGet victim.cs proj. Project's been cleaned. msbuild command line failed. Yes! None shall pass. So, that's pretty much all you need to know, really, which is probably just as well, because there's quite a lot to take in there. But what this shows is that you can build those, you can create those analyzers, you can create those standards, you can put them into your projects, you can build them with relatively low friction. I know there's a lot of detail to work through. I know that people are kind of going, wait a minute, syntax, symbol, why do I? I get that. But the actual level of friction you can see is relatively low. And that means that if you've got particular things that you want to do, that you want to share with your team as standards or as guides, then you can encode them this way, and you can make sure that they are brought up as warnings. Same as you would run with FXCOP in the good old days, but much more easily. And also much more interactively, because you get those warnings in line. But it's not just style guides. For example, you can also use this to pick up common errors. For example, one thing that I think gets some developers moving from other frameworks or other languages to .NET is some of the idioms are kind of different. For example, if you come from the Java world, in Java, the date time type, or I think it's called date, is a mutable type. If you want to create a new date, you just go, oh yeah, date.month equals whatever, and you get, and it modifies it in place. In .NET, you can go something like date.addMonths1, but it won't modify the date time object. It will return a new one. But C# will quite happily let you write mydate.addMonths1 and not complain about it. Now, you could go out and buy ReSharper, but this is a Microsoft corporate laptop. It hasn't got the oomph to run ReSharper. It barely has the oomph to run 7 instances of Visual Studio, let alone with ReSharper built in. So let's see what we can do about that. So in this case, you'll notice, first of all, that I've not put a code fix provider in here because I don't actually know what the fix is going to be if somebody does this, but I would like to kind of warn someone who's come from, say, a Ruby environment or a Java environment who might have different expectations about how certain types work, that, hang on, is this really what you meant to do? So how does this work? Well, we've got the same kind of boilerplate. We have a diagnostic analyzer somewhere up here. Yep, there we go. In this case, we're looking at a slightly different kind of thing. We're doing a syntax node action rather than a symbol action because we're not dealing with a declared symbol. But what are we doing with it? Well, we're doing a lot of walking of trees by the look of it. So we're trying to find, we've expressed an interest in member accesses, so basically where methods are being called. Simple member access expression. We need to walk up and find out, do we have an assignment, and do we have arguments? And if there's no assignment, then it tells us that the result is being used. Now, if there's arguments, the result isn't necessarily being used, but the arguments could be being evaluated for their side effects. So we can't make a warning in that case. So we have to say it's only if it's just a straight method call with no arguments and the result is not used. Then we will use the semantic model to look up what method is being called and deal with the fact we don't find out. If we have got a method that is being called, if we do recognize it, we'll look for the containing type and the member name, and we'll build, in this case I'm just going to build a string. You could be smarter about this. I'm just going to basically build a string, and I will then just compare it to my list of things that people on my team have got wrong, which I keep a notebook of. I'm really that petty. And if it's in there, then I will report a diagnostic. And that will come up as a green wiggly saying, hey, are you sure this is what you meant to do? And once again, I have tests that will show how to do that. Now, you may be thinking, this traversing of trees and all that sort of, this is actually beginning to look a little bit hairy. If it wasn't looking hairy already, it's now beginning to look distinctly hairy. How do you know about simple member access expressions and all of that kind of crazy stuff? And the answer is that I use the second scariest tool in the Roslyn toolkit. And I may show you the scariest one later on if we have time, but the second scariest one is quite scary enough. It is called the syntax visualizer, and it is a window that gets installed in Visual Studio, like that. And when you select some text, it shows you the Roslyn syntax tree. And you can't really see it on a monitor this size because it's enormous. But I will try to expand it enough that you can see the terrifying level of detail that Roslyn gives you. So let's maybe pick for this thing. So this is an example of a method call, and it's that expression statement, invocation, single member access, identifier name, identifier token, end of line trivia, white space trivia, blah, 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 blah. It goes on, and you can see the level of detail that Roslyn is giving you. And because of that level of detail, it is actually impossible to work out from first principles what you actually need to do with Roslyn. You have to basically fling it into Syntax Visualizer and go, what am I looking for? Write some example code of the thing that you're looking for, of the phenomenon that you're looking for, wave Syntax Visualizer over it and go, oh, of course, a simple member access expression. Who doesn't know that? And you can similarly use that to understand how those trees fit together. So you can also see that Roslyn is highlighting the bits that correspond to all of this stuff as you should. I mean, even that method declaration, you've got all of this stuff before you get to the block that's the body. It's very, very detailed. And the reason for that is to be able to round trip everything. If you create a syntax tree from something and then write out that syntax tree, you get back exactly what you started with. even down to the white space, even down to the people bickering about tabs versus spaces. You get back exactly the same thing. So the syntax visualizer is a very useful tool for that. All right. I want to show you one more thing in the analyzer and code fixing domain. Because I mentioned before that we kind of cheated with producing a new syntax tree, and I want to show you what it's like when you don't cheat. Why have I got two of those? Oh well, hopefully this is the right one. This is an analyzer for when someone has declared a private field. It's only initialized in the constructor, but they've left it as a read-write field, and it's going to suggest you should make this field read-only. So we've got the familiar analysis stuff. We check, is the field already marked as read-only? Is it non-private? Is it assigned outside the constructor? And the assignment outside the constructor, that requires a little bit more effort than we usually had, than we had before, because we need to think about the whole type in this case. It could be, we need to be looking through the methods and seeing, is that symbol used anywhere? The way we can do this is using a class called a C# syntax walker, which is an example. Roslyn uses the visitor pattern quite extensively. Are people familiar with the visitor pattern? Visitor pattern? It's the one that's known in the Gang of Four book as the scary one. Okay. Visitor is kind of a way that allows you to add a virtual method to somebody else's class hierarchy. So Roslyn has defined all of these syntax node types like class declaration, field declaration, method declaration, yada, yada, yada. They can't know what you want to do, what methods you would like to have implemented on those things. So they give you this visitor pattern that allows you to effectively add your own methods or add your own behavior via an object or a class of your own. One thing to watch out for, there's a thing called C# syntax visitor. You do not want to use this. That visits one node in the tree and then stops. And you go, why is it not walking the tree? Why? Why? What were you thinking? And eventually you Google around for a couple of hours and you find C# syntax walker. So that's what you want to use. C# syntax walker actually traverses the whole tree, and you can basically override methods on it to deal with things that you're interested in. In this case, I'm interested in two things, well, two and a bit things. Firstly, I'm interested in constructor declarations, because if I see a constructor declaration, I know I don't care about looking inside it. I don't care what happens to the field inside the constructor, because that doesn't affect whether I want to make it read-only or not. So I can just return from there. I don't recurse into it. The other one I'm interested in is assignment expressions. And here I just want to say, is the thing on the left the thing that I'm interested in? And if it is, then it's out. Then I want to say that is assigned is true, and I've got my smoking gun. This is another example, by the way, of the level of finicky detail that you need to think about these things, because I found out day before yesterday, that I had a gaping hole in my analysis, whereby if you went something like A++, I wasn't picking it up. So you need to be watching out for those cases. You need to understand the semantics quite well and how that is expressed in syntax quite well. What about the code fix for this? Well, again, the boilerplate's sort of fairly usual. We register a code fix, and how do we actually make the field read-only? Well, once again, in the rename example, we had a handy helper class, the renamer, because obviously renaming things is common enough that the Roslyn guys went, we're just not going to ask people to keep rewriting this thing that's traversed the entire solution renaming stuff. Unfortunately, they did not get around to writing the read-only fire, so we have to do that ourselves. And because immutable, it's not as easy as it should be. It's not difficult, you can see. But what we have to do is we have to create a read-only keyword token. And here you can see the appearance of syntax factory. If you do significant work with Roslyn, you will learn to hate syntax factory with the burning passion of 1,000 fiery suns. If I have time, I'll show you some code later, which basically consists entirely of syntax factory.x, syntax factory.y. There's basically a page of references to syntax factory just to make up like 2 lines of code. I'll show you how not to do that as well. So I use syntax factory to create a read-only keyword. I take my existing field declaration and I add that read-only token to it. But remember, that does not modify my existing field. It creates a new field declaration, which is the read-only version. Now I have to put that new one in place of the old one. So I have to get my syntax tree, get syntax tree to async, and it's got this handy replace node method, which will replace the node no matter what depth it's at. So I can now say, replace the old declaration with the new declaration. That gives me a new syntax tree. I can now construct a new document, which is the old one, but with a new syntax root, a new syntax content, a new C# code. And then I will return that new document, and that replaces the old one. So that when somebody does that control full stop, make that field read only, it will return this new thing, and that will get dropped in, and Visual Studio will do all of the diffing and all of that sort of stuff. Does that make sense to people? I know there's a lot to take in, but can people see the broad outlines? Is there anything people want me to drill into in more detail on the analyzers and code fix providers stuff? Does replace node cover all scenarios in terms of replacing things? That's a good question. I can think of... No, I think that's looking pretty good. I was thinking it might not cover the case where you want to replace one node with a series of other nodes, but it looks like it's got an overload for that. So I think that would cover most cases. I think that, yeah. And the potential difficulty, I suppose, is when you want to replace something that's at a middle level. But even then, what you'll do is you will take the existing thing, extract out the bits you want to keep, have a new thing that points to those bits that you want to keep, and then plumb the new thing in place of the old thing. So, yeah, I think replace node will cover most scenarios. Remove node is the other one, and insert node, obviously, is the converse to that, so if you're producing new code. All right. But Roslyn is not all about analyzers. You can use it to develop other kinds of tools. One thing that we've been talking about internally for our client SDK project is some static checks that we want to make on certain behaviors of the code. For example, because it's a library, whenever we do an await on an async method, we want to put .configure await. So we never want to do await such and such. We want to do await such and such .configure await, so that we don't screw up consumers of the library with threading models and stuff. And one of our testers has come up with a regex-based solution to this, for which I applaud him, but regex, it's not quite got the analytical power of a full C# parser, just wildly guessing here. He's basically saying, if I see an await, do I see a configure await somewhere later on, and do they look like they kind of match up? Well, that's about all I can tell. The other thing that he wants to do is to be able to audit the kinds of exceptions that we throw out of our client library. Because at one point we were throwing a rather embarrassing one, and we didn't want to keep on doing that. We wanted to have something that would say, are we throwing the kinds of exceptions we think we're meant to be throwing, rather than one that some developer has kind of gone, oh yeah, that looks about right. It's got the right kind of name. I'll use that. No, it means something. So I want to show you a tool for auditing exceptions. Now I've written this as proof of concept as a console application, rather than a test, but it could very easily be sort of ported into an XUnit test. You might, by the way, ask why not write it as an analyzer. There's two reasons. Firstly, not everybody will have Visual Studio 2015. In fact, the code base this is meant to run on is a VS 2013 code base. But I can still write Roslyn, I can still write the auditor using VS 2015. The other reason is that it needs to do quite a lot of scanning and analytics around the code, and projects wouldn't be performant in real time. It's the kind of thing where you're content just to run the tests and get it done. It doesn't need to be running on every keystroke. So what is this thing doing? Well, firstly, command line application, it's got a program, it's got a main method, life is good. And we're just going to do some stuff to get a list of thrown exception types and dump them all to the console. Some rubbish about parsing command lines, and then we get into the nitty-gritty of it. First thing I need to do is to open the solution that I want to analyse. Now, Visual Studio, this is kind of given to you on a plate as part of that context that is provided to your analyzer or codefix provider. If you're in a command line environment, or if you're coming at it from outside, you need to create a workspace. In this case, I'm going to use an MS Build workspace, and then I can open a solution in that workspace. And then I only want to look at certain projects, I don't want to do all of them, and I'm going to dive in and find out what exceptions each thing throws. In order to get at the syntax and semantic models, I need to do a compilation. That's not actually compiling to produce a DLL, it's basically just saying, run some Roslyn shit over this thing. Produce this sort of abstract rendition. It doesn't emit anything. And then having got the compilation, I can then go into that and get the exception type names off it. Now, again, look at me. I'm using a C# syntax walker to traverse the tree looking for where exceptions are thrown. Where might that be? Well, the obvious place is in a throw statement, strangely enough. So whenever I visit a throw statement, I'm going to look at, are we actually throwing something? Because C# supports the throw semicolon syntax, which just says throw the current exception. That's not a problem. We're not auditing exceptions that come up from bottom layers or whatever, or are rethrown. We also want to deal with a situation where someone has done catch exception EX, blah, 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 throw EX. Again, it's kind of not our problem if they're just rethrowing something. And then something that I found when I was analysing our code base was there were a lot of places where we were throwing something that was of type or of compile time type exception. I was thinking that's not good. We don't want to be doing throw exception. The reason for that was because we had some factory methods for creating exceptions, which I used to be able to show you, but the font size has changed. So I don't know if you can see, but here we've got, say, this unknown implementation type exception, which actually is an argument exception, but it's weakly typed in the return type. So at the throw site, I don't know that it's an argument exception. So I do some special magic to dive in and investigate those cases where it's obtained from factory. Now that is not a general purpose thing. That is not something that ReSharper or whatever is going to do for you. Well, George is probably going to tell me ReSharper would do it for you, but there's a plugin. Thanks, George. There's always a plugin, isn't there? But what this means is I can do static analysis based on the patterns of our team's code. I can look at the code base that I'm trying to maintain and tune my analysis to the peculiarities of that code base. And then I can drill into those and essentially look up what are the types of those. So I'm not going to drive through that, but you can see what I want to illustrate there is that I'm adapting to the particular kind of the particular structure of the code base. The syntax tree manipulation there is again quite hairy, and you will want to take a look at again so for example when we're doing a new, I want to be looking at the type of exceptions being constructed. Again, use syntax visualizer to figure that stuff out. All right. I want to show you two more quick examples. And at this point, So we've talked a lot about Torment. And you may be thinking, well, you talk a big game, but the way I see it, all someone has to do is scroll up and down a bit, and they won't see your annoying things. So, bring the Nagomatic. And at this point, I have to give a shout out to James Macaulay. Is he in the room? Is anybody here a colleague of James Macaulay? Right, you want to watch him carefully. He's got plans for you. So, James, you asked for Torment. Here is Torment. This is a Visual Studio editor add-in. This thing that's been around since Visual Studio 2010. In this case, it is an editor adorner, which is something that allows you to put sort of additional visuals onto the Visual Studio editor surface. And that's a pretty well-known thing. You can use that for adding wigglies or whatever. You can use it in a benign way. Or you can plug Roslyn into it. So again, this project was originally an adorner. I just added the Roslyn NuGet references. And you can now see that in my update field adornments, I'm using some Visual Studio integration. So this get workspace is a Roslyn method that is sort of a bridge between a Visual Studio text buffer and a Roslyn workspace. And this get open document in current context with changes, because if there's one thing that's longer than a Roslyn syntax tree, it's a Roslyn method name, gets me the document. Then I can do all my usual Roslyn stuff, get me semantic model, get me syntax model, get me the fields, get me the fields should be read-only, yada, yada. It's the same code as before. And for each line, I'm then going to go, if I've got a field that should be read-only and isn't, then I'm going to show you that good and proper. I'm going to torment you good and hard. And up this comes. This, by the way, goes into a different instance. This one is going into the white instance for reasons. And it takes a while. There we go. There's the Nagomatic text. And this is why I was banned from using WPF. If you comment this out at the right time, then you may be able to get them. Yeah. You like this. You're loving this. James is loving this. Excellent. All right. My work here is almost done. We're running very long time. I want to show you just one more thing, because I just think this is not entertaining, but I think it is supremely cool. And that is that you can also use Roslyn to do code transformations. And you can do this, you can hook this up to another Visual Studio feature called a single file generator. And if you've used stuff like, say, the visual designers in Visual Studio, you'll have used a single file generator behind the scenes, because that would be transforming, say, XML into C# code. What I'm going to do, before your very eyes, is transform C# code into C# code. All right. Here is my syntax. I'm not going to show you all the single-page hookup, because single-file hookup, but C# syntax rewriter. That is your rewriting class, strangely enough. I'm going to do something which adds notify property changed implementation, because old school you saw that was old school WPF. We need iNotify property changed. That means that when I'm visiting a class declaration, I'm going to need to add some backing fields. I'm going to need to add some events, and look at what it takes to add an event and a 2-line method. Look at it. It's glorious. Alternatively, you can cheat. You can just write the C# code and say, Roslyn, turn this into a node and put it in the syntax tree. And then you just walk away and nobody has to know. All right, what does this actually do? What does this do? So, coming up in the white instance, just taking a little bit of time. The Roslynizer. C# code, class 1, I know if I've already changed. Boring property, easy to write. Look at the properties of class 1.cs. It is not compiled, it is content. And it has a custom tool running on it, which means that whenever I make a change, the custom tool runs and it generates a file which is compiled, and it raises property change notifications, and it has a handler, and I don't have to keep writing that sodding boilerplate code every time I want to write a view model, because I can just have Roslyn generate the code for me through that single file generator magic. And by the way, in the event of any doubt, you can see I still, even though that's not compiled, I still get IntelliSense and all of that stuff on it. So you're not like losing out on developer experience. I think that is pretty cool because I'm so bored of writing that stuff. All right, oh, I meant to show you the scariest tool. I don't really have long, sorry. The scariest tool in Roslyn is the Roslyn Quota, which is an online tool that you can paste the C# code that you want into it, and it will tell you the set of Roslyn things, that you need to do to generate that. And look, class D, one little class declaration, produces all of that. Do you think I should? What do you mean 405? Okay, I curse you, Kirilosenkov. I'll have words with you. It's an awesome tool. It is really, really useful because figuring out the syntax trees is a pain in the arse, or you can just go past statement. All right, so tools and resources. The Roslyn Quota, when he puts it back up again, it'll be absolutely awesome. The syntax visualizer, second scariest. Bunch of learning resources. Look at that refactoring essentials sample. It's got lots of good stuff in it, and it's useful even if you just want to deploy it in your own thing. And Josh Varty's got an excellent series on learning Roslyn. Takeaways, you can make this stuff part of your workflow. If you're cutting across problems, if your retrospectives are always saying, oh, we should have done this, oh, we should have done that, if it's always the same thing, same mistakes coming up, build them into your workflow. Be pragmatic. Developing this stuff has got a cost. It takes time. Sometimes it's more effective just to detect an issue and leave it to be fixed by hand. And iterate. Consider what's worth implementing and what's not. And use your powers for good. Your developers, apart from James's colleagues, your developers are human beings. They do have feelings. You may not like those feelings, but people are creative. They're independent. They are smart. They are trying to do the right thing. Don't be too petty and bureaucratic. Firstly, they will hate you. And secondly, it will actually cost you because you'll get too many false positives. Don't be too prescriptive. Don't be too aggressive about these things because it's only code. It will have bugs. You don't want to annoy people with it. Samples are up on GitHub. I'll be around for a few minutes. Thank you very much for your time.